Hello and welcome back. Today I have another borrow from the Eleshop, and it's kind of an entry-level switch mode power supply, but it's priced really nice, and it is from MATRIX. It's the MPS 3206, so it can 32 volts by 6 amps, so that's quite a lot. And I like the size is very small, so. And it can actually do a lot of power for for its size. So let's have a closer look, and maybe we even have a look on the inside. Okay, here we have it. Yeah, it's a nice small size, and I think the height is more or less the same as these new multimeters, and I think you can just put two together as a size of one. So let me see the height. I'm measuring now with the feet, but it is, you see, 9.5, almost 4 inch, 9.5 centimeters, and the front is like 4.5 or 12, and you should be able to fit. You see here, you should be able to fit two, and the height also. Oh, you see, so that's no problem. You can fit exactly two. It looks nice. It has 5 memories, OVP, OCP, so over voltage protection, over current protection, and it has also thermal, so OTP if you would like. You cannot adjust the over temperature, but it will just switch off your voltage or amp settings, and you can switch on and off your outputs. There is an encoder, push button, and that's it. It has a 4-bit display, and well, let's just see the basic functions. Okay, now let's play a little bit. We power it on. It seems to come back to the value where you left it. So if I put this memory, and I will say voltage, and we wait, switch it off. Switch it back on, it stays in the value where you left it, so that is nice. As I said, 5 memories. You have the OVP and OCP, and the voltage and the current. Well, it just flips. So if we want to do the voltage, you can turn the knob, and when you push it, just switches a digit. So if we want to put 12, let's say 13.8. That's it. You want to do the current, you push the current. Let's say we limit it to 5 amps, and that's it. And if you want to use it, you switch on the output, and then the read of the amps will be what you're currently using. And when you switch off, then you have a readout what your current limit is. Oh, I like what I did with the current setting, where you set your constant current, that when your output is off, you can just clearly see what is the current you want to set it to, and when the output is on, you just monitor your current at the moment, what it is using your load. And because I remember with my man leaves right there, you could not even switch off the outputs, but also if you wanted to set your maximum current, you needed to short the connections, then you set the current, and that's it. But here, it's just easy. When you switch off the output, you can set your current, and when you switch it on, you see the current it's using right now. Okay, well, let's do a little practice test. Does the constant current work? Well, I put my load. Also, I like to mention that the colors are actually correct now. We have red for the positive, black for the negative. And if you really want your grounding, you have it, and it's green, just like you expected. Not like we see on the right, and that it is for a battery charging or some weird function. It is just the colors that you expect it to be. Well, I'm connecting my load. It is just a resistor load, and I can switch the resistance to get the load higher. it is just in 13.8 volt and 5 amps maximum, and if we switch on the outputs, then we should connect to the load. So okay, with the current resistance you can see it's in constant voltage mode because we set it to 13.8, so it's trying to keep it to 13.8, and currently we putting 1.358 amps through the resistors, and well, I can lower the resistance, and now we have 2.7 amps. Now we have 4 amps, and now I switch another resistor, and now you can see that the voltage dropped, and that is normal because now it switched over to constant current. So the current that the resistors actually are asking is a little higher than 5 amps, but because the power supply wants to limit it exactly to 5, it means it needs to drop the voltage. And well, if we set it to a lower value, we will see exactly the same, because here we have, so let's set it to 3 amps. So switch off the outputs, we can see our current limit, set it to amps, go to the correct digit, set it to 3, that's it. It's now set to 3 amps. Let's do the same, switch it on. And now it just needs to drop the voltage, and if I change the resistors even more, you will see, to keep this 3 amps it will drop the voltage even more, and that's why this one is called constant current. And now it is back to constant voltage mode. It's doing exactly what you expect it to do. Okay, let's do a quick test to see if the meter makes sense. It is here 13 volts. And I have here the Bremen. It's also from Eleshop.eu. It is the 869. I like it. And let's see if we switch it on. Is it like 13? Yes, it is 1302. So this last digit is just a fraction off. If we go to 30 volts, let's turn it up. 32 volts. Yeah, it's 3205, so it's fractional off. Let's see what the current does. Okay, I'm now connecting it between my load and just give it the full load. And here we read 3 amps. Let's see what we read in the meter. Look at that. The amps are super precise. That is good. Well, that all works as expected. It's a pity that the voltage meter was not adjusted that well, because it is like 20 millivolts off. It's not that much, but the current was just spot on, so very nice. Let's have a look how those memories work. Okay, we have here 5 memories, as I mentioned before, and let's see how that works. I don't see a store button or a recall button, so it's probably push once shortly to have the current memory, and probably if we do a long push it will store it. So let's see if that works exactly that way, and let's see if it also stores the current limit or it only stores the voltage. So I'm just going to set the voltage first. So let's do 3.3 volts. We use that sometimes for the Arduinos circuits, and I like to limit that, yes, to 1 amp, because that is okay. Long push. Okay, yeah, I think that's exactly how it works. Second memory, let's put 5 volts. 5. And yeah, also 1 amp is fine with me. Store that here. Okay, third memory. Let's put 9 volts. We want to do it instead of a battery, but then the current can be a lot lower. So let's put this back to 0 and put 100 millis. And we store that in 3. Okay, will it remember the current and the voltage? Yes, it does. Perfect. Well, that is easy to control. We can put this one, we can put 12. We could just override this one. volts, 3.5 amp is fine. Store it on memory 4. And then on this one we can put 13.8 volts, and let's do the maximum of 6 amps. I think it's actually 6.1 that it can do. Yes, it can. We do the 6 amps to limit, and we can connect our CB and store that in number 5. So then we have 3.3 volts 1 amp, 5 volts 1 amp, 9 volts 100 millis, 12 volts 3.5, and 13.8. Perfect. That works as you expected. Okay, that's what I like. I didn't need the manual, it just works as you expected. But something else I also noticed, if you can see in the back, there is a ventilator, but I didn't hear it. So that's cool. It's completely silent until it needs to be noisy when it gets hot. So I can try to put some load on it. I will use my electronic load and to see what it takes to make it noisy. But it has now, for now, it has been completely silent. So if you use low power, you don't get annoyed by the fan. Good thing. Okay, I have here my Kunkin 400 watts electronic load. And I also did a review about this thing, and also the modification for the power switch in the front, and also how to replace the bananas so you have proper terminals that actually are the standard size. So let's see if we put the load very high. Well, how many amps we want it to do? Let's put just 6. I will put 5 amps on it, and okay, I'm trying to find a position where you both can see them. So I will put this to 5 amps and put the load on. Then here, let's just go to the highest, 32 volts, and let's see if we can get the ventilator running. Putting it on load. No, it's limited now to 5 volts. A little bit less because of the resistance of the cables. And it means it's now doing 160 watts. And at some point, the power supply should get hot. And maybe the ventilator starts to run. Well, I needed to wait like 2 minutes. But now I will get my microphone a little bit closer. Now we can hear that the ventilator is running, and of course it is using now 160 watts for about 2 minutes, so of course it will do that. Let's see if it will stop. Okay, I can say this power supply is super quiet because as we saw, it took like 2 minutes on 160 watts to get the ventilator running, and then already when I took the load off, already within 20 seconds, it is already quiet again. So the ventilator is really effective, and it only switches on when it needs to. That works fine. I also have my effectiveness meter. So where I put the primary side and the secondary side, and then I can see how effective the power supply is, and it is a switch mode power supply, so it should be kind of effective. And I just wonder how much that is. I'm not sure how I am going to compare that, but just to see if it is on 160 watts, how much is it actually taking from the main power. So what I need to do is just put this in between, and also in between of my load. So I will just first connect it here. So it is switched on. Then I need to power the power supply from this plug. So I will get the wire for that. Okay, I have that here. Plug this in, this can go down. We put that in the back. Now, well, we can see it's 231 volts, It is taking 40 millis when it is inactive. Well, that is fine. The electronic load is still set to the 5 amp. So what I do, I put my load in here, and it needs to go through this one. So we are 40 millis. The output is nothing. Here we can see, I'm not sure if you can see the kunkin. Yes, you can. So let's see if we put the load on it. So we are actually using on the primary 160. We are using on this side 200 watts. So that means we lose like 40 watts, but that is still an effectiveness of almost 80%. I have set now the current limit to 2 amps, and as you can see, it's using now 64 watts. 64 almost here, that is correct, and it's 80 here, so it's 77.5% of effectiveness. So that means the higher the load is to the closer to the maximum, the more efficient it becomes. So let's see if I put it to the full. Okay, I have it now set to the electronic load to 6 amps, and 32 is the max. So let's see what we do. Yes, it is now like 190 watts. As you see, 190. It is drawing from the mains 240. So that means it is now at 78.7, close to 80%. So it's quite effective. I'm now comparing this to an analog power supply, and it should be a good one. It's HP. And the analogs are like 52%, and if I can do a little bit higher, 55%, and can I do 53%? So you don't get more out of an analog power supply, linear power supply. They are around the 50%. Well, I'm just using now my AMREL, and on the highest setting, that is 32 volts 1 amp, it is doing even below 50%. So that was a nice experiment. So we know that the old linear power supplies are below 50%, and the switch mode is 78, almost 80. But is that good or bad? So I found my MinLive here from Banggood. It is really, it looks like a lower quality, and you cannot switch on and off the outputs, and it doesn't have memories. But I just like to see if it is also just as effective. Looking at this little power supply, I'm putting more or less the same amount. Also 160 watts we have as a load, but this one needs more than 180 watts. And that means it's only 86%. So the matrix is actually also a little bit more effective. So when we have a look at the inside, you can see there is some extra support to make it more tight. So it's strong, that's good. The wires are nicely bound together. The components look straight. They did a nice shrink wraps. They put glue on all the connectors. That is nice. Looks like a proper heatsink. Yeah, it looks quite simple. Sometimes you see some cutouts in the PCB where the isolation is. You can't really see that. So they didn't do that. The cutouts, that caps here. I think to get the switching noise down. A real switch, not a soft switch. And you can see here that the grounding is also properly done on the screw on the whole frame. So they thought of most of it. So also on the inside, it didn't look bad at all if you look at it, because it's entry level, and I think you get a lot of your money's worth. I'm really amazed how easy to control it. The device is. It has the memories. It just works as you expect. I like you can set the constant current or your maximum current. You can set just by not having switched on the output exactly as you would want it, so you don't need to short circuit the connectors for that. And yeah, the possibility that you can switch on and off your output, that is really great, and that I really missed on the power supplies I bought a few years before, and this one doesn't. If you live in the Netherlands, you are in luck, or Belgium or close by. In Europe, then Eleshop will have these in promotion soon. So have a look at my links below. Thank you for watching, and I hope to see you next time.